During the campaigns across North Africa and the Middle East, soldiers faced an enemy more brutal than any army, the desert itself. Daytime temperatures soared past 120 degrees Fahrenheit, metal rifles burned to the touch, and the horizon shimmered like molten glass. Yet, amid these conditions, certain units learned to survive and even function without relying on scarce water or shade. Their secret wasn't luck, but clever improvisation. They used silver-foil cloths, salt crystal packs, and charcoal-lined headgear to deflect and dissipate heat when canteens ran dry. Long before synthetic fabrics and air-conditioned vehicles, these men built cooling systems from simple materials, systems so efficient that modern field researchers still study them today. In 1941, British, Italian and German troops found themselves locked in the brutal North African campaign, where sandstorms, dehydration and heat exhaustion claimed more lives than direct combat. The men stationed there learned one hard truth. Survival depended not on strength but on understanding the desert's physics. Every movement, every piece of gear had to serve the single goal of keeping body temperature below the danger point. Water was rationed, shade nearly non-existent, and uniforms soaked up heat like ovens. Then, through trial and shared experience, soldiers discovered materials and methods that exploited the desert's own extremes. They learned that reflecting heat, slowing evaporation, and creating microbarriers of insulation could protect the body even when the air itself felt like fire. One of the most fascinating examples came from the silver-foil cloth, a reflective layer used by both medical corps and pilots, later adapted by infantry and drivers stranded in the open. The foil blanket wasn't an invention of the space age. Its wartime ancestor was made by layering thin aluminum sheets or silver-painted fabric between cotton or linen backings. Originally issued for medical use to prevent shock, it quickly became a field survival essential. Troops discovered that wrapping this material loosely over tents or even draping it above themselves on poles could drop the temperature beneath by several degrees. It worked through reflection, bouncing radiant heat back toward the sky instead of absorbing it. Desert patrols sometimes lined the inside of helmets or canteen covers with the same material. A few field engineers even fashioned poncho-style covers out of salvaged foil from aircraft supply crates. The effect was immediate. Metal surfaces became bearable to touch, and body temperature stabilized long enough to prevent heat stroke during long marches. The secret was not to trap air, but to redirect sunlight away before it penetrated clothing layers. Modern survivalists can replicate this by using reflective emergency blankets as outer layers for shade tents, vehicle windshields or head coverings. The key is maintaining an air gap between the reflective surface and the skin, creating a miniature thermal shield. Even a thin layer of airflow beneath the foil prevents the build-up of radiant heat, the same principle soldiers relied on to endure endless desert days. Perhaps the most ingenious trick came from medics and mechanics stationed at desert airstrips. When refrigeration failed, they observed how salt crystals drew moisture from the air and cooled through evaporation. Applying this idea to personal survival, troops began filling small cloth pouches with coarse rock salt or halite fragments, sometimes mixing them with dry sand. When slightly moistened, even with a few drops of sweat, the salt created a cooling reaction as it absorbed liquid and released vapor. Soldiers tied these pouches around their necks, wrists, or under their helmets. The mild evaporative process drew heat from blood vessels just beneath the skin, helping cool the core without consuming precious drinking water. Some units went further, stitching salt layers between thin muslin wraps that could be re-wetted from condensation collected at dawn. For modern field survival, this same concept works. In dry climates, a dampened salt pouch or a bandana soaked in brine can lower skin temperature dramatically when placed over major pulse points. It's a low-tech evaporative cooler, one that uses chemistry instead of constant hydration. One of the least known but most effective desert survival innovations came from the early French and British colonial units. Their tropical helmets, known as pith or cork helmets, were lined with fine charcoal dust mixed with cloth padding. Charcoal, being porous and black, might seem counterintuitive under a blazing sun, but it worked by absorbing moisture and then slowly releasing it through evaporation. When the outer shell reflected sunlight and the inner lining evaporated moisture, it created a natural convection cycle around the head, cooling through airflow. During the Second World War, engineers stationed in the North African desert actually revived this clever trick. They made use of whatever they had on hand, spare charcoal from campfires and even filters from aircraft, to stuff into cloth liners. The results, well, they were truly remarkable. Head temperatures dropped significantly, which helped prevent dizziness and sunstroke, especially during those long, grueling patrols. To adapt this idea today, survivalists can, create similar headgear by sewing a layer of lightweight charcoal-infused fabric or even activated carbon cloth right between the outer and inner layers of cotton. When you lightly moisten it, it mimics evaporative cooling while filtering out dust and odors. It's honestly a simple adaptation, but with really powerful results, particularly in arid zones. The desert soldiers, they didn't just rely on one single invention. Their real advantage, in fact, came from combining three natural principles: reflection, evaporation, and insulation, to create a kind of balance. A reflective outer layer, such as foil or wax canvas, an inner absorptive layer like wool or charcoal cloth, and just a small amount of controlled moisture all work together to turn unbearable heat into much more tolerable conditions. Off-grid homesteaders and survivalists can, use the same system to cool shelters, protect food stores, or even make sleeping setups bearable in extreme heat. Reflective panels above a tent roof, salt-cooled wraps hung near airflow points, and charcoal-filtered fabric linings all mimic the adaptive genius of those World War II troops. Even when water is scarce, the environment itself can be harnessed to regulate temperature, just as soldiers did across Libya, Egypt, and the Persian Gulf. The story of desert warfare isn't only about tanks and tactics. It's about human adaptability. How ordinary men, armed with almost nothing, learned to turn the desert's deadly conditions into manageable challenges. Their cooling systems were not designed in laboratories. They were born from observation, necessity, and an understanding of nature's laws. Today's high-tech fabrics and hydration systems might offer convenience, but they often miss the essence of what those soldiers achieved: sustainable, self-maintaining survival. By revisiting their forgotten techniques, we rediscover principles that require no batteries, no plastics, and no dependency, just ingenuity and resourcefulness. The next time the heat feels unbearable, remember the soldiers who outwitted the desert. Their legacy isn't just in history books. It lives in every reflective tarp, evaporative wrap, and breathable shelter designed today. For more lost wartime innovations that shaped modern survival, subscribe to Echoes of Valor and share this story with fellow history enthusiasts. These forgotten lessons remind us that real endurance comes not from equipment, but from understanding how to work with the world itself.